Hello everyone, I am Balaji Rao. Welcome to BR Max class. This is third class in linear programming chapter. In first class, we learn all the definitions related to this linear programming chapter. In second class, what are the basic things that are required to do this linear programming problems and which we learn in linear inequalities chapter, those we quickly revise. In this class, I am going to do 3 problems in linear programming chapter. These linear programming problems are mainly divided into 2 types. One is bounded feasible region, another one is unbounded feasible region. I just want to complete all the bounded feasible region problems first. Later, we'll do all unbounded feasible region problems. Unbounded feasible region problems are little confusing one. I'll give clarity when we do those problems. This class is all about the problems based on bounded feasible region. These problems are very easy if you are clear with the procedure. We do these problems in 3 steps. Step 1 is using the constraints, identifying the feasible region. Step 2, after identifying feasible region, identifying the corner points, substituting the corner points in the objective function. Step 3. After substituting corner points in the objective function, we need to check as per the question. If they are asking for maximize, we'll look for maximum value. If they are asking for minimize, we'll look for minimum value. And then we'll conclude. You remember these things. 3 steps. Step 1. Using constraints, identifying the feasible region. Step 2. Find the corner points, substitute in the objective function. Step 3. Based on that corner points, we'll get maximum value, minimum value, and then we'll conclude. Before going to start this video, please drop a like for this video and share this video with your friends. Let's begin the class. Linear programming chapter. Exercise number 12.1, question number 1. In this chapter, mainly 2 types of problems are there. One is bounded feasible region, another one is unbounded feasible region. First, we'll complete all the problems which are having bounded feasible region. After that, we'll do all problems which are having unbounded feasible region. The problems which are having bounded feasible region are very easy, no confusion at all to understand in that. Let's see this problem. What they are asking in this question. You see what they are asking? Solve the following linear programming problem graphically. They are asking maximize this linear function. See, whatever they'll ask, either maximize or minimize, that is known as objective function. Objective function is denoted by z. In this question, objective function is z equal to 3x plus 4y. And they given subject to constraints. See, these are the constraints. Constraints means linear inequalities or conditions to maximize or minimize objective function. You please observe here, total how many constraints are there? This is 1, x plus y less than or equal to 4, x greater than or equal to 0, y greater than or equal to 0. Whenever these constraints are there, then you understand that whatever graph we'll draw, that we'll draw in first quadrant only. Because x greater than or equal to 0, y greater than or equal to 0 means the point x comma y lies in first quadrant. In first quadrant, x is positive, y is positive. So that's why whatever graph we'll draw, whenever you see like this, whatever the graph we'll draw, that graph will be in first quadrant only. Now, we graph this inequality. To graph this inequality, draw the line x plus y equal to 4. To draw line x plus y equal to 4, we need 2 points on this line. To find 2 points on this line, we'll go with this table. You draw one table like this. In place of y coordinate, you write 0. In place of x coordinate, you write 0. Now, you put y0 in this equation. Then what you will get? X plus 0 equal to 4. You will get x equal to 4. So, x value is 4. Now, in this equation, you put x equal to 0. then what you will get? You will get y equal to 4. So we got 2 points on the line. First point is 4, 0. Second point is 0, 4. Now these 2 points we need to mark on the graph sheet. Now in the graph sheet, I'll consider coordinate axis. Now you mark the points 4, 0 and 0, 4 on coordinate axis. See here, this is the point 4, 0 and this is the point 0, 4. Now you observe this inequality, less than or equal to 4 is there. Whenever less than or equal to, greater than or equal to is there, in that case we will draw the normal line. Otherwise we will draw dotted line. That also you will come to know while doing these problems. Here, as they given less than or equal to, we will draw a normal line. Now we got the line x plus y equal to 4. You name this line. This line is x plus y equal to 4. Okay. Now we need to find the solution of this inequality. That means for what values of x and y satisfies this inequality. To find the solution of this inequality, you observe this line equation. For this line equation, two sides are there. One is origin side, another one is non-origin side. What is origin side? You observe here, for the line, this side origin is there, na? So this side is known as origin side, and this side is there, na? This side is known as non-origin side. Okay, so here to find the solution of this inequality, as this line is having origin side, non-origin side, I'll put 0, 0 in the given inequality. Put 0, 0 in given inequality x plus y less than or equal to 4. You put 0, 0 in this, what you will get? 0 plus 0, that is 0. 0 less than or equal to 4. 0 less than 4 is true or false? 0 is less than 4. It is true. As it is true, you need to shade origin side of this line. You observe, I'll shade origin side of this line. This is the origin side of this line, correct? So you take any point in this side. Suppose if I take a point here, that point if I substitute in this inequality, it 100% satisfies. That means whatever the region is there, you please observe here, this red color part is there, na? Whatever point you take, substitute in the given constraint x plus y less than or equal to 4, it satisfies. So this is solution of this inequality. But if you observe here, another two inequalities are there, that is x greater than or equal to 0, y greater than or equal to 0. It indicates that our solution is in first quadrant only. Actually, for the first constraint, you got this is the solution. As they given x greater than or equal to 0, y greater than or equal to 0, our solution will be in first quadrant only. So what is the feasible region now? You please observe. If I take this region, you please observe this. This is in first quadrant, right? In this first quadrant, if you take any point, that point satisfies all three constraints. I hope you are understanding. If I take a point here that satisfies only this x plus y less than or equal to 4. So what is the feasible region now? You please observe here, the shaded part is there, na? This light green color, this shaded part is there, na? This part is the solution, feasible region. This feasible region is bounded or unbounded? This is having closed area, na? That's why clearly we can say that this is bounded feasible region. In this linear programming problems, whenever the given problem is bounded feasible region problem, the problem is very easy, no confusion at all. I need to maximize this objective function under these constraints. For that, I am just graphing these inequalities. After graphing these inequalities, I got the feasible region. After getting the feasible region, first step is over. First step is what? Graphing these inequalities. This problem can be divided into steps wise. Step 1, graphing this inequality. See here, graphing is done. Okay. Second step, identifying the corner points. You observe in this feasible region, we can easily understood that these are the corner points. This is simple problem. These are the corner points. We already learned in first class what are corner points, right? These are the corner points. You identify the corner points and write the corner points. Step 1 is what? Graphing the inequalities. Step 1 is over. Step 2 is what? Identifying the corner points. Here 3 corner points are there. Na? Identify corner points. What is this corner point? This corner point is 0, 0. What is this corner point? This corner point is 4, 0. What is this corner point? This corner point is 0, 4. You mark these 3 points. So 0, 0, 4, 0, 0, 4. So you got total 3 corner points. These 3 corner points you substitute in objective function. They given maximize z equal to 3x plus 4y. You substitute 0, 0 in this. What you will get? 3 into 0 plus 4 into 0. That is 0. Okay. Now you substitute 4, 0 in this. Substitute 4, 0 in this. 3 4s are 12 plus 4 into 0 is 0. So what you will get here? This is 12. Okay. Now you put this point in this objective function. What you will get? 3 into 0 plus 4 into 4 is 16. So you got 3 values here. Step 1 is graphing the inequality. Step 2 is identifying the corner points and substituting in the objective function. Now step 3, as the feasible region is bounded feasible region, you observe what they are asking in the question. They are asking maximize the objective function. As they are asking maximize the objective function, in these 3 values, which one is the maximum value? 16 is the maximum value, correct? 16 is the maximum value. That means this objective function is maximum at this point 0, 4. So what I'll write here, final conclusions. Therefore, z equal to 3x plus 4y objective function is maximum at 4, 0. And what is the maximum value? Maximum value is 16. What they are asking in the question? They are asking us to maximize this objective function under these constraints. So what we got? We got that this objective function is maximum at this point and its maximum value is 16. I hope you understand solution of this problem. You observe the second question. In exam, they'll ask solve this linear programming problem graphically. After seeing this question, you need to understand that this is the objective function. They are asking minimize this objective function subject to these constraints. That means these are the conditions. Under these conditions, for what values of x and y, this objective function is minimum, that we need to identify. This problem we will do stepwise. What is step 1? Step 1 is we'll graph these inequalities and we'll identify feasible region. If you observe here, these are the 2 main inequalities are there here. Now we need to graph these 2 inequalities. Okay. After that, if you observe these 2 inequalities, x greater than or equal to 0, y greater than or equal to 0, it indicates that our graph will be in first quadrant only. Graphing this inequality is nothing but finding the solution of this inequality, finding the values of x and y which satisfies this inequality. First, I'll draw the graph x plus 2y equal to 8. To draw a straight line equation, we need 2 points on the line. To draw this line equation, I'll consider this table. Now what I'll do, I'll put y equal to 0 in this equation. You put y equal to 0, you will get x equal to 8. So I got 1 point on this line. That point is 8, 0. Now in this equation, I'll put x equal to 0. If you put x equal to 0, you will get 2y equal to 8, y equal to 8 by 2, that is 4. So this point is 0, 4. So I identified 2 points on the line. One is 8, 0, another one is 0, 4. From these 2 points, I can draw this line. Before going to graph this inequality, I just want to draw this line also. Finally, in the graph, we will identify the things. To graph this inequality, I need to draw the line 3x plus 2y equal to 12. To draw this line, I need 2 points on this line. So for that, I will consider this table. Now, in this, you put y equal to 0. Then what you will get? 3x equal to 12. So x equal to 4. So 1 point on this line is 4, 0. Now, I will put x0 in this equation. Then you will get 2y equal to 12. So you will get y equal to 6. So this point is 0, 6. Now I got 2 points on this line. What are those? 4, 0, 0, 6. Now on the graph sheet we will draw these two lines. To draw this line x plus 2y equal to 8, I will mark the points 8, 0 and 0, 4. You observe 8, 0 point is there on x-axis, 0, 4 is there on y-axis. You observe this is the inequality they given. In this inequality, less than or equal to is there. When less than or equal to is there, then we will draw normal line. Other than that, if they given strictly less than or strictly greater than, then we will draw dotted line. Okay. So as they given less than or equal to, we will draw a normal line. Now we need to find solution of this inequality. As we drawn this line, for this line, origin side, non-origin side are there? Yes. You observe this is the origin. This side of the line is origin side of the line. Okay. This side of the line is non-origin side. As there is origin side, non-origin side is present for this line, I will put 0, 0 in given inequality. In x plus 2y less than or equal to 8. So in place of x you write 0, in place of y also you write 0. Then you will get 0 plus 0 less than or equal to 8. That is nothing but 0 less than or equal to 8. Is 0 is less than 8? Yes, 0 is less than 8. It is true. As it is true, as we got it as true, we will shade origin side. That means whatever values you take here, all the values satisfies this inequality x plus 2y less than or equal to 8. You just keep it in your mind that this side we got, right? So at the end I will shade feasible region. Okay, we graph this inequality. Graph of this inequality is this part. So this is solution of this inequality. Now I'll identify solution of this inequality. So what are the 2 points on this line? Here you see 4, 0, 0, 6. 4, 0 and 0, 6 on the graph sheet. As they given less than or equal to, you just draw normal line passing through these 2 points. You please observe this blue line. For this line also, origin side, non-origin side present. This is origin side and this side is non-origin side. As origin side, non-origin side present in this, I'll put 0, 0 in this inequality. You put 0, 0 in this inequality. Then what you will get? 0 plus 0 less than or equal to 12. That is nothing but 0 less than or equal to 12. Is 0 is less than 12? Yes, 0 is less than 12. So this is true. As this is true, which side we need to shade? When it is true, we will shade origin side. If it is false, non-origin side we will shade. Okay, so for this line, which side we need to shade? Keep it in your mind that this side we need to shade. Okay, you please observe these are the constraints they given. What we identified, we identified solution of this inequality towards origin side, and we identified that solution of this inequality is also towards origin side. As they mention in the question, x greater than or equal to 0, y greater than or equal to 0, our solution will be in first quadrant only. Now, you please observe the feasible region. Feasible region means common region. This is the common region which is present in first quadrant. I hope you are understanding what I am trying to say. This is the common region determined by given inequalities. Correct? When we shade towards origin side for both the inequalities, as they given x greater than or equal to 0, y greater than or equal to 0, this is the common region determined by all the inequalities. In this red color zone, if we take any point, that point satisfies all these inequalities. So we identified feasible region. In class 11th linear inequalities also we learned these things, right? And this feasible region is bounded, closed area is there. So this problem is going to be easy only. So first step is over. What is the first step? Identifying the feasible region. We identified the feasible region and we found that it is bounded feasible region. Now second step is we need to find the corner points. What are the corner points? You please observe. For feasible region, corner points. For feasible region only corner points. You see, total 4 corner points are there. In these 4 corner points, you know this is 0, 0, this is 4, 0, this is 0, 4. This we do not know, right? This is nothing but point of intersection of this point is nothing but point of intersection of these two lines, right? As we need to find the corner point, this is point of intersection of these two lines. So what I'll do, I'll solve these two line equations to find this corner point. So I'll solve these two line equations. You observe when we subtract this 2y will get cancelled. 3x minus x is 2x. 12 minus 8 is 4. So you will get x equal to 2. Now I'll substitute x equal to 2 in this equation. You put x equal to 2, what you will get? 2 plus 2y equal to 8. From this, 2y equal to 8 minus 2, that is 6. 2y equal to 6, y equal to 3. So we got x equal to 2, y equal to 3. So what is that point x comma y? That point x comma y is 2 comma 3. Now we got this point. What is this point? This point is 2 comma 3. Now we know all the corner points. This is 0 comma 0, this is 4 comma 0, this is 2 comma 3, this is 0 comma 4. Step 2 is identifying corner points and substituting these corner points in the objective function. Now we got 4 corner points. Now all these 4 corner points I'll substitute in the objective function. 0 comma 0 in this, then what you will get? You will get 0. Now you put 4 comma 0 in this, then what you will get? You will get minus 12, right? This is minus 12. You put 0 comma 4 in this, then you will get 16. Okay. Now you put 2 comma 3 in this, then what you will get? Minus 3 into 2 plus 4 into 3. That is minus 6 plus 12, that is 6 only. If you observe the question, what they are asking in the question, they are asking maximize or minimize. You observe here, they are asking us to minimize this objective function. After substituting corner points in the objective function, what is the minimum value? You observe here, minus 12 is the minimum value when we compare with all these values. So what we got here? We got that minus 12 is minimum. This is the minimum value. So as the feasible region is bounded feasible region and we got that here minus 12 is the minimum value, we can conclude here. See, if the feasible region is unbounded, procedure is different. As the feasible region is bounded, we got the minimum value here. I'll conclude this. I'll conclude that therefore z equal to minus 3x plus 4y is minimum at 4 comma 0. And minimum value, what is minimum value? And minimum value is minus 12. They are asking us to minimize this objective function under certain constraints. So we came to know that this function is minimum at this point 4 comma 0 and its minimum value is minus 12. Hence this problem is solved. I hope you understand how to solve LPP problem graphically. You observe this third question. They are asking maximize this objective function subject to these constraints. That means under these conditions we need to maximize this objective function. To maximize this objective function, first we graph these inequalities. Okay, so to graph this inequalities, graphing this inequality is nothing but finding the solution of this inequality. What values of x and y satisfies this inequality, that we are going to find. To graph this inequality, first I'll draw the line 3x plus 5y equal to 15. To draw this line, we need 2 points on this line. To find 2 points on this line, you consider a table like this. Now you put y equal to 0 in this equation. Then you will get 3x equal to 15. From that, x equal to 5. So we got 1 point on this line equation, that is 5 comma 0. X equal to 0 in this equation. Then you will get 5y equal to 15. Y equal to 15 divided by 5, that is 3. With the help of these 2 points 5 comma 0 and 0 comma 3, we can draw this line equation. Before graphing this inequality, I'll try to find 2 points on this line 5x plus 2y equal to 10. You take the equation 5x plus 2y equal to 10. I need 2 points on this line. To find 2 points on this line, you just consider a table like this. You put y0 in this equation, then you will get 5x equal to 10, so x equal to 2. So 1 point on this line is 2, 0. Now you put x0 in this equation, then you will get 2y equal to 10. From that, y is 5. Now I got 2 points on this line 5x plus 2y equal to 10. Now I'll draw these two lines on the graph sheet. To draw this line 3x plus 5y equal to 15, you mark the points 5, 0, 0, 3 on the graph sheet. This is 5, 0 on x-axis, 0, 3 on y-axis. You draw a line passing through these 2 points. Now this red color line is 3x plus 5y equal to 15. Now we have the line 3x plus 5y equal to 15. Now we need to graph this inequality. To graph this inequality, if you observe this line, for this line, this side is origin side, correct? Because origin is this side, and this side is non-origin side. As origin side, non-origin side present for this line, you put 0, 0 in the given inequality. You put 0, 0 in this inequality, then you can observe that 0 plus 0 is less than or equal to 15. So you got that 0 less than or equal to 15. Is 0 less than 15? Yes, 0 is less than 15. So you got true. Once you got true here, which side we need to shade? When we got true, we'll shade this side. So you shade this side. In the process of graphing this inequality, we got like this. What is this yellow color part? This is solution of this inequality. If I take any point on this inequality, when I substitute in this, definitely this satisfies. So this yellow color part is what? This is solution of this inequality. Now I need to graph this inequality. For this, we already calculated 2 points on this line. What are those 2 points? 2, 0, 0, 5. You mark these 2 points on the graph sheet. See here, 2, 0 point is here, 0, 5 point is there here. Now you join a line passing through these 2 points. So what is this line? This line is 5x plus 2y equal to 10. If you observe, for this line, origin side, non-origin side is present. See, here origin is there. Na? For this blue color line, this side is the origin side. Now, as this line contains origin side, non-origin side, I'll put 0, 0 in this inequality to graph this inequality. You put 0, 0 in this inequality. Then 5 into 0 plus 2 into 0 less than or equal to 10. So what you will get? You will get 0 less than or equal to 10. Is it true? Is 0 is less than 10? Yes, it is true. As it is true, we will shade origin side of this line, right? So you can observe this is origin side of this blue color line. Now you shade this part. Now you see this blue color shaded part. This blue color shaded part, what is this? This is solution of this inequality. That means in this zone, if you take any point, that point satisfies this inequality. That is the solution of this inequality. Now you identify what is the common region. What is the common region formed by these two inequalities? You can observe this lightish green color type we got here. This is the common region determined by these two constraints. If you observe all the constraints in the question, they given these constraints. You please observe Now we graphed these two inequalities. Now you see here x greater than or equal to 0, y greater than or equal to 0 also given. What are these? These are the non-negative constraints. It indicates that our solution is in first quadrant only. Now you observe the common region satisfying these inequalities in first quadrant. You please observe. This is the region which is satisfying first inequality, second inequality, as well as non-negative constraints x greater than or equal to 0, y greater than or equal to 0. So what is the feasible region? Please observe this. This is the feasible region. You observe here this highlighted part is there. This highlighted part is the feasible region. Is this feasible region is bounded or unbounded? This feasible region is clearly bounded because it is the closed area is there. Now what to do? We need to find corner points. You observe here corner points 1, 2, 3, 4. Total 4 corner points are there. We know this point is 0, 0. This point is 2, 0. This point is 0, 3. We don't know what is this point. This point we need to find. As we are doing this problem stepwise, step 1 is graphing these inequalities, identifying the feasible region. That is completed. Second part is identifying the corner points. For this 4 corner points are there. These points we already know. To get this corner point, we will solve these two line equations 5x plus 2y equal to 10, 3x plus 5y equal to 15. Solve these two line equations to get this corner point. You multiply this first equation with 5. Let's see what you will get. 5 5s are 25x, 5 2s are 10y equal to 5 10s are 50. Now the second equation you multiply with 2. If you multiply with 2, then it will be 6x plus 10y equal to 15 2s are 30. Now you subtract these two equations. When we subtract, this plus 10y minus 10y will get cancelled. 25x minus 6x is 19x. 19x equal to 50 minus 30, that is 20. So what is x? X is 20 divided by 19. Now you put this x value in this equation to get y value. 3 into 20 divided by 19 plus 5y equal to 15. This is 60 divided by 19. You take it to the right hand side. 15 into 19 is 285 minus 60 divided by 19. 5y equal to 225 divided by 19. 5 in this 225 45 times. So you will get y equal to 45 divided by 19. So you got here x equal to 20 by 19, y equal to 45 by 19. So what is the point of intersection of those two lines? 20 by 19, 45 by 19. So you got this point. This point is 20 by 19, 45 by 19. As we got all these corner points, step 2 is identifying the corner points and substituting these corner points in the objective function. Now you substitute these corner points in the objective function. You put 0, 0 in this, then what you will get? You will get 0. You put 2, 0 in this, then what you will get? You will get 10. When you put 0, 3 in this, then you will get 9. When you put this point in objective function 5x plus 3y, then you will get 235 divided by 19. Now step 2 is also completed. What is step 1? Step 1 is graphing the constructions and identifying the feasible region. We identified that this feasible region is bounded. Step 2 is identifying the corner points and substituting the corner points in the objective function. That is also completed. Now step 3 is conclusion. As they are asking, maximize this objective function. In all these values, which one is the maximum value? You please observe, this is the maximum value. 235 divided by 19 is the maximum value compared to all these values. As they are asking maximize, the feasible region is bounded, we can conclude here. If the feasible region is unbounded, we cannot conclude here. That we will do when we do unbounded feasible region problems. Now, what is the conclusion I can give? Therefore, the objective function z equal to 5x plus 3y is maximum. At what point? At 20 divided by 19 comma 45 divided by 19. And what is the maximum value? And the maximum value is 235 divided by 19. Hence, we solved this linear programming problem graphically. I hope you understand solution of this problem. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Take care. Bye-bye.